Okay, so what we have is another Cauchy-Euler differential equation. And to try to streamline the process up enough, we've substituted y equals t to the mu quite a bit to kind of know how this plays out. And remember that when you do that, the t squared y double prime becomes mu times mu minus 1. The t times y prime becomes 9 times mu. This is after you substitute, collect all your powers of t, and then realize that t to the mu is a common factor, and then factor it out. So then this becomes a 25 and now equals 0. So there's your equation in mu. That's again what we call our auxiliary equation, not the characteristic equation, because this is a different equation, finding different things. So if we collect our like terms and whatnot, we're going to have mu squared plus 8 mu plus 25 equals 0. And the goal is to find mu. So what I'm going to do, instead of using quadratic formula, because I have a coefficient of mu squared that's equal to 1 and an even coefficient of mu, I'm going to use completing the square. So mu squared plus 8 mu equals negative 25. And then what we do, we take half the coefficient of mu, which is 8. So take half of that, which is 4, and square that and add that to both sides. And that guarantees the perfect squared trinomial on the left. So we have mu plus 4 squared equals negative 9. And that means taking the square root of both sides, we have mu plus 4 equals plus or minus. Now the square root of negative 9 is 3i. And that means mu is equal to negative 4 plus or minus 3i. So when those are the solutions to the to the auxiliary equation, we have a special kind of solution that gets written. Now remember, everything is based on y equals t to the mu. Just like with the characteristic equation, everything was based on y equals e to the lambda x. So it should be no surprise that with imaginary solutions, we end up with sines and cosines. So the solution is y is equal to c1. I'm going to leave some room in c2. Now, the real part tells you what happens with t to the mu. So this is going to be t to the negative 4. And the 3i tells you something that goes into the sine and cosine. So this is going to be a cosine here and a sine here. And this one's a little bit tricky. It's not 3t, it's 3 natural log of t. And that's your general solution. So there we have it.